Our video today is going to take us through integers, how to work with them when you have multiple ones, combining them and multiplying them. Some rules to live by in this section is when we combine our numbers, we want to let the signs tell us what we're doing. And when we're multiplying and dividing, we're going to find that the rules are the same. And then we're going to deal with odds and evens, especially with the multiplying and dividing section. So with integers, we have what are called opposites. As you can see in the diagram here, we have a positive 3. The opposite would be a negative 3. If we have a positive 1, we actually have a negative 1. So when we talk about opposites, we're really looking at multiple signs in front of a number. If you remember the rule, when you have more than one sign, of odd number of negatives is going to that's going to equal a negative. If you have an even number of negatives, that's going to give you a positive for that section. And we really don't care about the positives when we deal with this, so we can cross those out, because if a number is given, it's not going to have a sign. We always say it's positive anyway. So, using the opposites, we're going to simplify some signs in front of some problems. So we're going to start with first one here. We're looking at counting the negatives. We have 4 even number of negatives, which would make it a positive 2. If we take a look at the second one, again, we can cross out or get rid of the positives. We don't need those. Gives us an even number of negatives, which would make it a positive 5. Our last problem that we have, we're going to simplify this. We're not going to solve it. We'll do that later. Is we have two negatives in front of the 2, which would make it an even number of negatives, which would give it a positive 2. We have odd number of negatives in front of the 3, which is 1, so it would give us a negative. And then we have a odd number of negatives here, and we don't care about that. So we have an odd number of negatives, which would give us a negative 2. This is now the problem that we can go ahead and start solving. One of the other concepts in the integer section that we're going to deal with is absolute value. This is the symbol for absolute value. It looks like two parallel lines with the number, in this case an x, representing that number inside of it. The definition of absolute value is simply the distance the number is from 0. It's neither positive or negative. So we're just looking at from 0, what's that distance value, and it doesn't matter if it's positive or negative, it's still just going to be that. So one of the definitions that I asked you to remember is, if you want to remember this big one here, that's fine. This would probably be the easiest one of the two. It's just simply the number. There is no sign attached to it, so you have to take into account what you're doing with the absolute value here in order of operations of getting the problem solved. So with your combining rules, you're going to let the signs tell you what to do. So in our first part here, with both of these situations, the rule is same sign, add the numbers, your sign will carry. For the opposite, if you notice on this one, I have a larger positive here, a larger negative here. Larger positive gives me a positive. The larger negative gives me a negative. So what we say is that different signs, you subtract your numbers. The larger number is going to carry the sign for these rules. This is once you've simplified down your signs in front of your numbers. So if we put this into action, we're looking at, you have in the first problem here, you have 2 signs in front of the 10, so you're going to have to simplify those down first. So that's going to give you 2 negative 10, because we have an odd number of negatives, which we would take different signs, subtract them, which would give us an 8. the larger number in this sign, or the number in this problem, is 10, which would give us a negative 8. So we can say that different signs we subtract, larger number carries. In the second example, we have two signs again in front of the 10 that we have to simplify, which would give us a negative 11 and a negative 10. So in this case, we have the same signs. So we could say same signs, we're going to add the numbers. The sign is going to carry, so it's going to be a negative 21. In our last example, again, we can get rid of the positive if we want to think it in that way, which gives us a 2 and a negative 19, which again, we have different signs, so we're going to subtract, which would give us 17, the larger number here being negative 19, which would give us a negative 17 for our answer. So here's a shortcut for you in remembering those little symbols. So with multiplication rules, they're really simple. Again, we're looking for odds and evens. So if we have an odd number of negatives, we're going to get a negative, and that goes to this case down here. If we have an even number of negatives, we're going to get a positive. So that's all you have to really worry about. The other one is your division rules, and your division rules will make it really simple. They are exactly the same as the multiplication rules as you work the problem. You just divide the numbers. So with this, you have 4 problems, 2 multiplication, 2 division. And when you do the multiplication division, it's easier if you kind of take it in steps. So I kind of break this down into 2 simple little steps that you want to do. Doesn't take that long to do, but it makes your problem a lot easier to work with. So the first thing is deal with your signs. So take care of your signs first in the problem, and then take care of your multiplication or division of the numbers. That way you don't have to worry about 2 things at once. You're kind of separating it out, making it a little bit easier problem to work with. So if we look at the first example here, we're going to take a negative times a negative, which gives us a positive, and then we have 3 times 22, which would give us simply 66. Now we don't have to put the positive. If you want to, you can. You won't see it in the assignments. But it's just a way of knowing that, okay, it is a positive number. But again, with a number that doesn't have a sign, unless you're dealing with absolute value, it will always be positive. So in our second example here, we have a negative times a positive. So if we have an odd number of negatives, that's going to give us a negative. And 6 times 8 is just simply 48. And in this case, we do need the negative in that part of the problem. So for division, again, we're looking at the whole problem and what is dealing with here. So we look at it as, okay, we have an even number of negatives in this problem here. So that would again be a positive, and then 24 divided by 8 would just simply give you 3 for this one. So in our last example here, we have 42 divided by a negative 6. So again, we have an odd number of negatives, which would give us negative. 6 into 42 is going to leave us a value of 7. Now the other thing that you can think of when you're looking at it, if we look at this problem just by itself, is you can think of it as this negative outside is asking you what is the opposite of this. So when I get done with, if I just took this problem all by itself and said, okay, I have 24 and a negative 8, that's going to give me a negative 3 because I have an odd number of negatives. But what this negative out here is saying is, what is the opposite of that negative 3? Well, the opposite of a negative 3 is just simply 3, and that's kind of where you look at it. So you're asking yourself, what is the opposite if it's outside of that? Or you can say, even in here, you can say 24 divided by 8 is 3. Well, what's the opposite of that? Would be a negative, and then what's the opposite of that would be negative. So you're looking at what is the opposite of that if there's a negative outside in front of that number. So now we get into a little bit bigger problems in regards to the order of operations of this. So we throw this stuff at you as a part of it. And you have been working with order of operations for a number of years. So these are the steps of your order of operations. remember when you get to here, it's left to right, and here it's left to right. But one thing about this in regards to left to right is go left to right. Don't think, well, it says multiplication first, so I must do that first, even though it's not in the left side to go to right, or addition going left to right. If you have subtraction, that's your first part of the problem, going left to right, you need to do that first. So it's more important to follow this part of it than it is what is in order of what's written in the order of operations of multiplying, dividing, adding, and subtracting, because that's generally how we just say it in the first place. So we have a couple problems here. We're going to take a look at the first one, and we're going to go ahead and solve it. So again, we're going to follow order of operations. Now, one of the things that I try and do is I try and highlight what I'm doing first, and then I just bring down what I don't work with the answer of what I just did. And that just kind of cleans up your problem, but it also kind of sets the table for what you're going to do in the next step. So again, I have multiplication division here. I have to get rid of that first before I go through and do my adding and subtracting. So again, here's where if I follow the adding and subtracting first, I would go and add the 6 plus 7 and then take that from 9, and that's going to give me a wrong answer. So I need to go left to right here. So I'm going to take this one third. I'm going to get 9 minus 6 is 3 plus 7, and that gives me 10 for my answer. So if you would have went 6 plus 7, that would have given you 13. 9 minus a 13 would not give you a 10. It would give you something completely different. So if we take a look at our second problem, we have some things that we have to do first, and that is we have to simplify the signs in front of the 6. So we really have to do the negative negative is a positive. So again, what is the opposite of a negative 6 if you want to think of it that way? And now I can start working the process of order of operations. So I'm going to do what's inside the parentheses. First in the problem, this was actually the first thing I did to get ready for the problem. So I end up with 6, negative 4, 10 minus 4 gives me 6. Now I look at this and say, well, I've got to multiply next. So I have 6. I have an odd number of negatives here. 6 times 4 is 24. So when I subtract this for my third step, I end up with a negative 18. Do that a little bit better for you. So I end up with a negative 18. Because again, larger number carries, different signs I subtract. So that's the process of working through it. So some key factors to remember for the video that we went through today with integers is with your combining part of this, when we talk about combining, we can say the same signs we add. So same sign, add the numbers, sign carries. Different signs I subtract. Larger number carries. And that carries the sign. So these can be just little codes that you can have for that. We'll probably be doing something in class to help you with that as it goes along. The other thing you want to remember is what the absolute value is. Absolute value is simply just the number. You want to make sure you count the signs that you're working with, count the negatives. Remember, we don't care about the positives. Multiplying and dividing, we're going to work off of the odds and evens. The biggest thing that you want to make sure is if you start working the problem is simplify signs when there is more than one number or more than one sign in front of the number as you go through it. If you do that, you will be fine with this section as we go through it. So take your notes, use them, apply them to what we're doing in this problems, and you'll be successful in the integer section.